what we're really going to be covering today is some framing around why a semantic approach can be beneficial when doing recommendation and information discovery, and really get into the process for establishing a recommender. So looking from the business and the technical side, an interdisciplinary approach of how to make semantic recommendation engines a reality. And we're going to be talking about this in the context of real case studies. Both Sara and I have built and led the development of multiple semantic recommendation engines in different enterprise contexts. And so we're bringing those lessons learned and here and kind of bringing the thematic best practices and toolkit for success. So a brief introduction, so you know who you're with today. My name is Sara Nash. I'm a principal consultant at Enterprise Knowledge. We're a knowledge management consultancy based in the DC area. And my role at EK is really leading the implementation of knowledge graph solutions, some in their early pilot and prototyping stages, getting folks off the ground. I'm also working on knowledge graph products that are at that, from the keynote this morning. They're moving towards from semantic data products to enterprise semantic data layers, and so have experience kind of across that spectrum of maturity. And I'm joined by Sara Duane.
Yeah, hi everyone. Nice to meet you all. My name is Sara Duane. So we're a team of Saras here. I am a senior technical analyst at Enterprise Knowledge. And I've really been part of both the analysis work as well as the project management side of things for enterprise semantic recommendation engine solutions in the healthcare industries and the government industries, as well as construction as well. And so this is something we love talking about. And so thank you for joining us. We're really excited.
Awesome. So let's start. What is a recommendation engine, and especially in the context of semantics? And the real framing here is around information retrieval. And there's been kind of an evolution in the way, I think, especially we as people and as consumers have gone about retrieving information and discovering new information and knowledge. We started with a world of search and kind of needing to do more active discovery. And so initial knowledge modeling was really around how to enhance search through things like synonyms or alternative labels, or kind of building out the base knowledge into to kind of search indexing. We've also been in the space of using things like facets or filtering and modeling metadata to help with the process of information retrieval in more of that active sense. But there's now more of a need or an expectation for people to do more passive discovery. And there's multiple reasons for that. I think one is, as consumers, we're seeing more and more of that in our daily lives, where content and information is pushed to us that is expected to be relevant based on different information. Maybe it's a product that you also bought, or products that other people bought. Maybe it's the music that you've been listening to. And so it's important to have kind of knowledge modeling to help to drive those kinds of recommendations. The reason why recommendation solutions are really desirable is it gets into a point of personalization. People are expecting within their organizations to only see content that's relevant to their department or their role. As when we're creating customer experiences, we're expecting people to be finding information that's relevant to them, either as a more of a technical user or a salesperson, and how you can kind of build in that kind of personalization. And so this is kind of the expectation. And so it's how can we build that experience of recommendation and more passive information discovery. And these are examples of things that we experience every day. Netflix recommendations, Amazon. These are products that you also might see, and Spotify. And so there's more of a need, and what we're hearing from our clients is they want to build similar solutions internally, either for information discovery within their organization to help with process efficiency, to help with onboarding. That's hugely important, as there's such turnover within organizations. How you can actively prepare people through more passive information discovery. They're also wanting to create those experiences for their customers, and it's because of these products that are making that a reality in our everyday lives. And so we've had success in kind of creating these experiences within a variety of different industries. So, for example, with a workforce development, so basically a healthcare training organization, they wanted to be able to push relevant course content to their users. So, if someone's taking an assessment about their ability to treat a particular, you know, type of diabetes, and they have a question wrong, they want to be able to actively recommend content that they would be able to further develop out in that topic area. Another example of a success story within the semantic recommendation engine space was around a project 360. So when you have people that are all kicking off a new project, how can you compile all of the resources from around the organization that are relevant to that project? Previous project plans, news, and policy developments that might inform the kind of variations on that project. So these are ways that we're kind of helping to drive information discovery. So we've taken these success stories and the kind of the best practices in building out successful recommendations across these to bring you sort of a framework for how to achieve this in your organizations. So, and one thing that it's important to define before going too far is, what do we mean by a semantic recommendation approach? So there's multiple different types of recommendation engines, and some of the traditional recommender approaches are more through machine learning and using user analytics to drive personalization. So basically saying these users have acted in similar ways that might help to drive recommendations. The challenge for that for many organizations is there's a huge amount of data, that's the kind of training data that's required to make these types of recommenders successful. These also don't capture sort of the nuance, and I think this goes back to the message in the keynote this morning around wanting to make sure that for some recommendations, recommendations that we worked on around recommended courses to take for particular regulations, there's a really high bar in terms of what that recommendation is. It might not be a high bar for, if someone doesn't like a TV show, but if you're telling someone this is the content you should take to be able to remain compliant with something, there's a high bar for that recommendation. And so you need to have what we call explainable AI, or sort of a traceability in terms of how that recommendation is made. And so that's where you come into a semantic recommendation approach, where it doesn't require a lot of user analytics or data in that sense. And you can start small and really build out your domain and make recommendations that are fact-based, based on the domain, and able to be iterated as you're seeing your results. So I'm sure you're wondering, how can we make that possible? And so we're going to talk about this step-by-step process in the context of this particular case study, which was with the healthcare training organization. And they had previously had a manual process in terms of trying to push out their training content to users, and it wasn't scalable. And so they wanted a way to be able to continue to provide relevant training content to their users in, when they get a question wrong, or when they log in. This is new content that would be relevant to them. And so we built out a recommendation service that, with a knowledge graph as the back end, to serve multiple of those different use cases. And it really came down to domain modeling and understanding the content and providing recommendations based on that. So Sarah's going to jump in with the how-to there.
Wonderful. Yeah. So we wanted to talk through our approach for building out this recommendation engine that we used for this specific case study, but also the others that Sara talked through at the beginning of the presentation here. And so we'll walk through kind of from start to finish these different frameworks and steps to the approach, from defining out that use case to creating those data models, constructing the graph, applying logic, and then lastly, integrating with key systems. What I want to call out before I go into the kind of detail on each of these steps here is the kind of iterative cyclical nature of this approach. And so you can loop it back and bring in additional expanded use cases, expanded classes on your ontology after you go through this approach once, to build out and expand with different use cases. And so this case study that Sara just talked us through is one that we've worked on in multiple iterations. And so we've built out different inputs, different outputs for slightly different versions of use cases. So we've gone through this approach multiple times and have been able to build off of it. So we'll start with the defining the use case. And I think with a lot of development work, often we think about defining our use case as thinking through and considering and characterizing our key persona. And then what is the key user story, the key core problem statement that they're looking to solve. And of course, that's still important in our context here, but I think it's also important with this recommendation engine journey to think about more specifically inputs and outputs to our recommender and how that impacts the journey of a user. So in this kind of image we have up on the slide here, we're thinking towards what is the trigger input. What is 1 to 3 things, 1 to 3 items that a user of your recommendation engine would know and be able to input to then start the process of generating these recommendations. We've also identified, what is also the known information, the other key metadata that we might have about those key inputs. On the other end of things, of course, we have what users are getting out, those outputs. So we, during this defining the use case process, you need to think towards what is the minimum amount of information that a user would be able to take away from the recommendations in order to make them actionable. And on the other end of that, we also think about what is other known information about the output we can associate after the fact, after the recommendations are made, in order to give more context. Think a description or an audience, that type of thing. Of course, in the middle here, we have what facilitates these connections, and I'll talk about that more in the next couple of slides. And so when we switch over to this next slide in terms of the step of creating those supporting data models, what you're seeing on the screen here is an example, a simplified example of one of the ontologies that we built out for this use case that we walked through in the healthcare training space. And so what we did after we decided these key inputs, these key outputs, was model out an ontology that defined the business domain of the healthcare training space. And so what you're seeing kind of on the left here are these key inputs, and on the right, the key target content, those key outputs. And so what this is doing is allowing for the connection of shared relationships, and that's really what generating these recommendations does. It's built off of these shared connections and relationships. And so one of the iterations of this use case, this example that we worked towards, was in the healthcare space. There are multiple types of medical competencies that healthcare professionals need to be able to know in order to be successful in their jobs. And there's multiple ways you can evaluate these types of competencies, from assessing via a test question. It might be assessing via a checklist of items that a nurse can watch someone walk through and know that they know what they're doing. And so what we did through this model was assess out creating these recommendations of questions and checklist items based on shared criteria of whether the input was a skill-based competency or a knowledge-based competency. But then, of course, the key middle piece of things are really those shared topical relationships. So if you think about the potential for our input to be about a specific medical symptom that someone may be facing, then you think about how that might relate to a specific treatment that treats that symptom. Maybe the treatment is associated with a specific prescription of a medication. So if your question, your checklist, considers that medication, it's a great way to kind of thread the needle, if you will, and connect back to that input. And so, we have to think also of how we're getting this data to fit the model that we've built out. And so we think of it, in kind of summary of three ways. The first being creating that data. And so you can think of this, in our example here, through something like creating out a comprehensive topical taxonomy. It may also be creating a new metadata field that you'd like to associate with one of your key inputs. In the middle here with data enrichment, this is really about leveraging the key value of data through adapting and kind of iterating on it. You might think of this as tagging the unstructured content with some of this topical taxonomy and this control list that you've built out. And of course, lastly with data integration, this really connects back to a lot of the value of knowledge graphs, is that we're able to integrate, to connect data sources and key data insights across data sources to be able to construct and add in this data to our graph despite its location. And kind of an exciting part of the process here is deciding how you'll apply and define the recommendation logic that really allows for the ranking, the weighting of the recommendations that you're receiving. And so we kind of like to think of this in two main types of approaches here, the deterministic and the statistical. And so when we think to why one might choose a deterministic method here, we're thinking towards getting very explainable, targeted types of recommendations. It's a use case for choosing deterministic is something, as Sara was talking to, the case where you need very accurate targeted results. You'll be building a domain, through modeling the ontology and the data models. And so having this deterministic approach allows you to get targeted results within that domain. When we think towards statistical methods, the use case for this really is when the scope of your data or your content is very large, and when there's really an investment from the business and the organization to build out a large set of training data. It also scales, well in that sense, but it is important to think about the potential con there. Is that it's harder to change very kind of targeted logic within the statistical approach of things. And so with this use case that we've been talking through, we definitely leveraged a lot of deterministic logic methods here. I talked a little bit about filtering when I talked about getting either a test question result or a checklist based upon whether the competency was a skill or a knowledge-based competency. So limiting the result sets based on a specific shared criteria or characteristic. Boosting is being able to impact and increase the weighting, the result of a recommendation based upon whether it shares that criteria. So not limiting it, but boosting that up. And traversing in the middle here, doing that pathfinding, those shared relationships that we kind of talked through on that data model slide. On the statistical side of things, really about kind of determining the probability of shared relationships in classes based on those weighting algorithms. And so, we won't go into the kind of technical nature of this in too much depth. But if you want to hear more about that, actually two of our colleagues, Holly and Fernando, are speaking about the technical approach of recommendation engines tomorrow. And wonderful. The kind of last, step of this key approach here, of course, is how are we using this recommendation engine? How do we interact with it? So we've been talking through this process about, one of the ways that we interact with it is through something like a content microservice, being able to recommend content to a user at their time of need. We also think of this in terms of chatbots and intelligent assistants in that way. And so we all, I think, know and understand the really value that a graph can add to a chatbot in this case, where without that graph, a chatbot really is looking at input intent and input without the larger domain, the business domain modeled behind it. And so the ability for a chatbot to understand the kind of intuitive human business domain behind it gives it that more explainable targeted results. And of course, we think towards enhanced search as well, and providing out those personalized search recommendations and results. And so I hope this approach gives you kind of a step-by-step guide towards how we built out that recommendation engine for this client, how we do that with multiple other clients in this space as well. And so now you might be thinking, okay, great. Well, what is the kind of foundational, what are those key aspects that I need in order to make this approach a success? So Sarah's going to kind of round us out with that, those considerations.
Awesome. Alrighty. So the toolkit for success, and we could probably have a full separate talk just on these, but we did want to cover off on how these are really the key elements to making your recommendation engine a success. Firstly, is around really building out the case for what the business value will be for a recommendation engine, and starting that, making it very clear. Who will this be used for? What are the kind of revenue implications and the ways that this can really benefit the organization? So that's really, really important. And these are some of the key value propositions, particularly in the recommendation space. In terms of tooling and architecture, we didn't dive into this as deeply, but did want to kind of touch on, these are the kinds of solution set that's required in terms of building out the solution. So your taxonomy and ontology management tool, orchestration, ETL, graph data storage, this is all part of this ecosystem that can support your entire kind of knowledge graph ecosystem, and certainly semantic recommendations. And then lastly, these are the types of team members or skill sets that can provide that interdisciplinary support in creating out semantic recommendation solutions. So again, happy to talk about any of these in more detail, but we do want to leave time for any questions that you have.
So you said there was like the deterministic and then the statistical recommendation approach. Like in your experience, can you give like a percent split? Like is most of it deterministic with a little statistics sprinkled in, or how does that work?
Yeah, it's a good question. And I think one thing to call out too is that they can complement each other very well. So it doesn't have to be kind of a one or another type of approach. You can really leverage the kind of core parts of that deterministic model through filtering, through boosting, through traversing, while also leveraging statistical models. I don't have necessarily a percentage of one versus the other. I think we've seen both, pretty consistently throughout our projects. But I think calling out that kind of complementary nature is important in that sense as well.
And, oh yeah.
Sorry. So I was kind of assuming you did both. So I'm saying like you implemented both, but what percent of the recommendations are just statistical and what percent are deterministic?
Oh. So I think it depends on the solution set, in that for this healthcare recommendation system, we went fully with the deterministic approach. So 100% of the recommendations could be traceable in that deterministic sense. For solutions that we've done for more of a hybrid approach, it might be, really when we bring it in hybrid, the statistical pieces actually come typically earlier in the pipeline, where we would be using machine learning, large language models, things like that, as a way of extracting knowledge from content to build out the knowledge model, and then introducing a more of a an interactive modeling to then build out the deterministic process. So in that sense, 100% of the recommendations would be deterministic, but in terms of where the knowledge originated, it could have been through a statistical method. Is that?
Yeah.
All right, Steve, question.
For the even though with the hybrid approach, for the statistical part, what libraries, languages, or tools that you use? Because there's a variety of them. So when it comes to enterprise knowledge work, what tools, what libraries, packages, software would you recommend, or do you have, just?
I know. Well, I hate to do this, but I almost want to just plug tomorrow's presentation with the folks who are right in front of you. Fernando and Holly will be.
Leave your hands.
Yeah.
Send them.
I don't want to steal their thunder, but there's it. To be honest, I feel like we've used different approaches also based on the existing tooling and skill sets within an organization. So if an organization is more Python leaning, we would use certain Python libraries, those kinds of things. This use case, we used AWS microservices architecture, and they're going to go into it more detail tomorrow in terms of libraries. Yeah.
To what extent are you including personal information about the user and feeding that back into a knowledge graph, i.e. the results of previous sessions, the preferences of an individual user as opposed to the needs of their general role?
Yeah, that's a great question. And for the most part, how we've seen the progression is starting with the domain modeling as your first initial use case, and then the next phase of expansion is bringing in personalization based on user activity, and both user activity and characteristics about the person. And so in this healthcare use case, we started with the recommendations that were just based on the kind of topical relevance between disparate content items. And the fast follow was, okay, what do we know about the person? If they're a nurse, it's actually important that they have content that's more related to their nursing. So that's kind of one style of personalization, which is based on characteristics of the user. Then you can also extend with kind of analytics, and this is what this is how people have been interacting otherwise. All right. Fire drill. Thank you. Awesome. Thanks.
This is tomorrow, 11. Okay, I want to.